Welcome back. We learned single phase, three phase output equation and also voltage equation as or EMF per turn of a transformer. And also we have seen the overall dimensions and how to design the transformer steps and all. Okay. So next important session in the point of exam point of view is design of core. Okay, since we have gone to telc and all for IVs, you will be familiar with many terms like stacking, then core, stepped core, cruciform core, like that. So you have studied, you have seen everything in telc. So design of core. So moving on to design of core. First thing we need to know the stacking factor. So what is stacking factor? Stacking factor is denoted as Ks. Okay. So AI is equal to Ks into AGI, whereas AI is the net core area and AGI is the gross core area. So stacking factor is basically the ratio of net core section to gross core section. Okay, AI by AG. Normally Ks value is from 0.85 to zero point 0.9. So in question, if stacking factor is not given, you can take it as zero point 0.9 or you can take a 0.85 to zero point 0.9, any range. Normally we will be taking like zero point 0.9. Okay, so moving on to the theory section, just read this. The transformer core, normally you all know what is stacking. അല്ലേ, അടുക്കി അടുക്കി വെച്ചേക്കും. നമ്മൾ കോർ സെക്ഷൻ നമ്മൾ കണ്ടപ്പം ടെൽക്കി പോയപ്പോഴത്തേക്ക് നമ്മൾ കണ്ടതാണ് അല്ലേ, എല്ലാം സ്റ്റാക്ക് ചെയ്ത് വെച്ചേക്കുവാണ്. ഓക്കെ, സോ ഇറ്റ് സ്റ്റാക്കിംഗ് ടുഗെദർ തിൻ ഷീറ്റ്സ് ഓഫ് ലാമിനേഷൻ giving the required core section, and also these laminations are insulated on both sides. ഇതെല്ലാം നമ്മൾ ടെൽക്കി കണ്ടു. We have seen everything in telc. Okay, so that is stacking factor. Next we need to know utilization factor. So that is the ratio of net cross sectional area to the gross area of the core circle is known as utilization factor. So utilization factor is the ratio of net cross sectional area to the gross area of the core circle is known as utilization factor. Normally if the utilization factor increases only if the number of core steps are increased. Optimal number of step is normally 6 for smaller transformer and 15 for larger transformer. So therefore improvement in utilization factor increases core area, therefore it increases voltage per turn. So if utilization factor increases, it in turn increases the voltage per turn. So the core section for core type can be, this core type can be rectangular, square or stepped. Okay, and also the shell type transformer normally use rectangular type cross section. So this can be normally asked in gate level questions and all the core types, or the like rectangular, or it will be asked like this. Shell type transformer use what type of cross section, like it can be asked. So it use only rectangular type cross section. So rectangular type cross section is only used for shell type transformer. And in the case of core section for core type transformer, it can be rectangular or square or stepped. So moving on to the rectangular core, for core type distribution transformers and power transformers and small transformers for moderate and low voltage, rectangular type core section may be used. Okay, so rectangular type core type is used where in the case of core type distribution transformers, power transformer, then small transformers for moderate and low voltage, rectangular core types cross section may be used. Normally the ratio of depth to width of cores varies between 1.4 to 2. So these ranges in EMD we need to study all the ranges. Okay, we there should be we won't be having any data sheet or anything. We need to remember or memorize somehow these ranges. Rectangular shaped coils are used for rectangular cores. For a shell type transformers, width of limb is 2 to 3 times depth of core. Okay. Next is square stepped core. So when circular core require for high voltage distribution power transformer, for circular core it is used for high voltage distribution and power transformer square and stepped core is used. Okay, so square or stepped core is used in power transformers. With core type transformers of small size, simple rectangular core can be used either circular and rectangular cores. As the size of transformer increases, it becomes wasteful to use rectangular cores. For this purpose, square shaped cores are normally used. So normally we prefer only square shaped cores, because if the size of the transformer is increased, this rectangular cores will become wasteful. Therefore, we go with the square typed core. Okay, so see here, this is the square type core, and small d is the circumscribed circle. Okay, and this one is the cruciform core. So this is the core and this is another core. This is this cruciform core. Okay, and with large transformers we can go with the cruciform cores. And for the sometimes for the exams, design of core can be asked in the essay session. So if possible you need to study these also. Okay, so in the case of square core, small d is equal root of a square plus a square. So here a is equal to 0.71 d. You need to know this equation. A is equal to relation, a is equal to 0.71 d in the case of square core. Okay, and also this AI is equal to 0.45 d square, and also this ratio is 0.5 d and this ratio is 0.64. So mainly you need to know small a value and capital AI value for problems. And in the case of two-stepped cores, this derivation is simple. Okay, it's not that much lengthy derivation, is simple. AGI is equal to this A into B, AB plus B into A minus B. Okay, and this A, what is this A? A is equal to D cos theta and B is equal to D sin theta. So substituting that, we will get this relation, and you need to know this AGI and AI value. Okay, so this is the figure of two-stepped or cruciform. You need to learn this figure and the values also. And this is the three-stepped and four-stepped. So you all have to learn this two-step, three-step and four-step, these figures and also these values by heart. Okay, and also this table is very much important for gate also. They will be asking these values. Okay, so this term is very much important. So for AGI, for square it is 0.64, for cruciform core it is 0.79, for three step and four step it is 0.8487 respectively, and also AI. And also we need to know that AI is equal to KC d square, where KC is for square core it is 0.45, for cruciform it is 0.56, and 3 step is 0.6 and 4 step is 0.62. Okay, so this table you need to learn by heart. It's very important for doing problem as well as in the point of questions that's asked for gate also. These values we need to know: AGI, AI, this step for square, cruciform 3 step, 4 step, and also this AI and KC values. Okay.